All right, today we're going to talk about summation notation or series. So notation-wise, this is what it looks like. So this is the Greek letter sigma, and this basically the whole idea is about series, and it's taking a sequence and then adding all the terms together. So like A1, A2, A3, A4, etc. would be the terms of your sequence, but now you're going to add them all together. Down here, this is where you start. And then this is going to be whatever you end at. So you start by plugging in 1 for this one, and you just keep going into whatever n is. So if it's 5, you plug in 1, 2, 3, 4, 5, add them all up. So some examples to try. This first one, I'm going to start with 1. So your first term is going to be 3. And you're going to plug in 2, so you get 6. And then 9. And then 12. And the last one you want to plug in is 5. So your last number is 15. Add them all together and you should get 45 as your answer. So to put underneath this was k equals 1, k equals 2, k equals 3, k equals 4, and k equals 5. Same idea for the next one. You want to start at 3, so you get 9, and then you plug in 4 to get 16. And plug in 5 to get 25, and that's where we're going to stop because we're going to stop at 5. So it's not saying do 5 terms, it's saying go until you hit number 5. So the answer is going to be 50. And then this last one, plug in 1, we get x, 2, you get 2x, 3, you get 3x, 4, you get 4x, and your answer is going to be 10x. All right, so a little bit more complicated. Here we have some infinities. So I'm going to start writing them out just so you can see what's happening. So sine of pi is the first term. Then you want sine of 2 pi. And then sine of 3 pi, etc. So what is sine of pi? To go back to your unit circle, you should be 0. Sine of 2 pi is also 0. And then also 0. So this is just going to end up being 0. So even though it's an infinite series and you're adding things continually, you're just going to add up and end up being 0. So this next one, let's do a similar idea. We'll get 3 over 10, and then 3 over 100, and then 3 over 1,000, and then 3 over 10,000, etc., etc. So I'm going to rewrite these as the decimal so you can see this. We'll get 0.3 for this one, 0.03, 0.003, 0.0003. So if you add this all up, you're going to end up being 0.33 repeated, which is the same as a third. So then writing them out. So here we're given a sum or a series, and we want to figure out what is the formula. So hint number 1 is we need to figure out what's the explicit formula first. So to go from 25 to 32, you add 7. To go from 32 to 39, you add 7. So it looks like a nice arithmetic sequence. So you can write that out as this formula from before. The first term is 25, and our common difference is 7. So if you simplify this, you'll get 7n plus 18. So this is what's going to go as part of our sigma notation. So I'll rewrite that here. We want 7n plus 18. And then we'll say we start with n equals 1. Doesn't really matter what you pick as long as when you plug it in, you get 25. And now we need to figure out what goes on top. What's our n term? So take whatever the last term they give you is and set that equal to your formula. And then solve. So subtract 18 from both sides, divide by 7, and n will end up being 8. So then you can put 8 on the top right here. And that is your sigma notation. So one more. Figure out the pattern first. So the pattern here is going to be multiplying by -2. So it's an arithmetic sequence. We can plug it into this formula. So the first term is 3 times -2 to the n minus 1. And that, again, is going to go into our sigma notation. Start with n being 1, and now you have to figure out what is your last term. So set up this equaling your formula. Divide by 3 on both sides, and you'll end up getting 4,096. And then this is where you have to remember how to solve. So we've done this kind of solving before, but you can rewrite this as an exponent and get log base -2 of 4,096 has to equal n minus 1. So at this point, you can type this log into your calculator, but a note, this is going to have to become positive because otherwise you can't take the log of a negative number. So you can do change of base, do log of 4,096 divided by log of 2 and get an answer, or you can type this in as it is if you have a nicer calculator. So this will end up being 12 equals n minus 1. So then n equals 13. And you can put the 13 up here, and that is your formula. So again, Google videos on the Fibonacci sequence if you want, and check Schoology for your homework. And that's it.